All right, guys, how do we solve such problems? So let's look at the whiteboard. So the first question is x e to the x tangent x. How do we find the derivative of that? So what we do, we mark the top functions as f, g, and k. And you remember there is this traveling derivative thing that I mentioned. So it is f prime g k plus f g prime k plus f g k prime. Then what? The derivative of f is just 1, right? X is disappearing. So this is e to the x tangent x plus here the derivative moves to g, and g is not affected by derivatives, so we have x e to the x tangent x plus finally we take the derivative of tangent, so we have x e to the x secant squared x. That's the derivative of tangent. What do I do if I forget? If for some reason I forget the derivative of tangent, then I can write it like this. Derivative of tangent is a derivative of sine x over cosine x. And for that, we may simply use quotient rule. Remember quotient rule? What do? You square the denominator, copy the denominator, take the derivative of sine, subtract. Now the roles are reversed. It's now the derivative of bottom function times top function. And what you get is that numerator is simply cosine squared plus sine squared divided by cosine squared x, or 1 over cosine squared x, which is secant squared x. As simple as that. Yes? Now, let's see what other question do we have here. The other question is 7x squared minus secant plus secant cosecant, yes? So how do we take derivative of that? 7x squared minus secant x plus secant x cosecant x. What's the derivative of that? That's simple. It is 14x. Derivative of secant, tell me in the comments, what's the derivative of secant? Quickly. Derivative of secant. Secant tangent, Zohab. Wonderful. Secant tangent. It rhymes. And if you forget, you know how to recover it. So it's minus secant x tangent x. That's the derivative. Plus, now here we have product rule, right? So product rule, we take derivative of first function. Don't bother the second. So derivative of secant, it's here secant x tangent x cosecant x plus derivative of cosecant. So I keep the secant x intact. Derivative of cosecant is minus cosecant x cotangent x. And we are done. Yes? I'm working fast, guys. You know that I am pretty behind, you might imagine, right? But don't worry, no matter what, we will cover all the material, or you cover it. Yes, we are strong. So next question is, I kind of don't want to bother with it. You know how to deal with it, or should I go over it? It's e to the x plus 5x squared and cosine x tangent x. All right, so I guess I'll do it. So it's derivative, we need kind of a lot of room, of cosine x. What did I say? Cosine x, did I? Cosine x tangent x. Cosine x tangent x divided by what? Divided by 5x squared plus e to the x. You see, one thing to do here, notice cosine times tangent can be simplified because tangent is sine over cosine, yes? So before I do anything, I might want to simplify my life because I don't want to use quotient rule and product rule. So I simply see that cosine times tangent is sine x divided by 5x squared plus e to the x. And then it's a simple application of quotient rule. So we have 5x squared plus e to the x squared. Copy the function. Times the derivative of sine, which is cosine, minus derivative of bottom function, which is 10x plus e to the x multiplied by sine. Good? So there is nothing interesting about this particular function, so we are going to leave it be and move to better things. All right, so let's talk about trigonometry. By the way, have you voted, guys? Do you know this joke, right? If you are young and vote Republican, then you have no heart. But if you are old and work Democrat, you have no brain. You never heard of it? Well, hear it from me. Here you go. All right, so onwards. I heard it from one person. It was my relative. Looked like a mafia guy. Right? Everybody was afraid of him. It was very nice though, to me. Yeah, I don't have a heart. You know, when I drive a car, I think left is where my heart is. You see? But I am dyslexic. I have no idea where is left. So let's go on. So guys, some people are actually in my probability class are placing bets. You know, they got so excited about expected value, so they started placing bets, even though, you know, I don't know any data about it. So next question, very important question, guys. So we have learned this. We have learned that limit as h goes to 0 of sine h divided by h equals to 1. Let me remind you why that limit works. So I can draw a circle. Not bad, actually, right? I'm improving with my handling of this instrument here, right? So I draw a circle, and here both h of sine and h on the bottom are measured in radian units. So you think of a crust of a pizza for which the angle is small. And then what you do is, where do you see here the h? The h is the length of the crust in radian measures. Here is h, and here is sine h. So this is sin h. No, Alan, careful. Wait, I'll get to cosine. Do you see this? Sine h is just, guys, so that it's very, very simple. H is the arc of the crust of the pizza, and vertical segment is here, this vertical red segment is sine. It's just measuring this vertical segment at this angle and seeing how long it is in radian units. You understand? So it's very natural to use radian measure both for angle and for H. Okay, now why is this 1? I will show you actually an animation to remind you why this is 1. Now this here is cosine H. Okay, so we just have the horizontal leg of a triangle is always cosine H. The vertical leg of a triangle is sine H. And they are measured, of course, in radius units, you know? So basically when you say sine H, it means measure the vertical leg in radian units. Cosine, measure the horizontal leg in radian units. So the claim that sine H over H is 1 is the same as to say that numerator and denominator are essentially the same. Make sense? You with me, guys? Make sense? So they are essentially the same. That's how can you get 1? It's that when H is small, numerator and denominator are essentially the same. So that means that this red vertical line segment is the same length almost as this arc. Let me show you again the video. Okay, so let's look at the video for a moment. So you see the animation here. So it's not the one I wanted. This one, guys. Look at it carefully. Look at it. I pressed pause. Can you see the screen? You all see the screen? You see, look at it. The angle is 0.217, which is what? It's roughly 22% of the length of the radius. That's what the angle is. It's here, and I laid it flat on the x-axis, right? And then sine is 0.215. You see how close they are? So this length and that arc are very close. So what you have is when the angle is small, they are very close to one another. Now let's see what happens if I work a little farther. You see now the difference is still not too bad, but there's a difference. The difference is growing. You see, the bigger is this arc. This arc is now here. It's laid flat on the x-axis. Here is the arc. I just cut it out, place it on the x-axis, and I create this triangle here. You see this, and then the red segment here, right? So they are essentially the same length. So this vertical side as the horizontal are essentially the same. And of course, the difference becomes more significant. You see, if the angle is big, so now the angle is much bigger than, it's already somewhat bigger than 1 radius. Sine is below 1 always, right? And you can see the difference is becoming larger. You see, here the angle is almost 2 radians and sine is almost 1 radian, like 91% of a radius, yes? So you understand what this statement means? It's pretty intuitive. Good? And what about the other limit? The other limit is here, guys. Look at it. I draw this segment. This segment here is 1 minus cosine of H. Yes? 1 minus cosine H. And now if you look at this arc, so you have this, if I draw it on the side, you have this segment, you have this vertical segment, and you have something that would look like a hypotenuse. It's actually curved, but kind of like a hypotenuse if the angle is very small. Are you with me? So what you have is that essentially this length is the same as this length. So that means that the orange length is essentially 0, even compared, right? So basically in comparison in this picture, it's a right triangle. The square of the red plus the square of the orange equals the square of the blue, which means this guy is very close to 0. I'm giving you not formal arguments, but intuitive arguments, which means the orange compared to blue is almost 0, which you will then expect that you expect this to be true, guys. You expect that limit as h goes to 0 of what? Of of 1 minus cosine h divided by h, you expect it to equal to 0. Okay, so we know those two limits somewhat. I'm not claiming that my arguments are very convincing right now. I'm just hoping that they convince you enough to have an intuition for why this is the case. I have a much more convincing argument down below. Yeah. So far, guys, could you please confirm if you follow my lecture and you understand everything I have been talking about so far? Please write something like yes or Y if you're lazy to write yes. And Mr. Tesler? Ikraf understands me. Catching up. Okay. Good. Sehr gut. So you see, look at this limit. That if this limit is 0, and then in particular, this limit would also be 0, right? So limit as h goes to 0 of cosine h minus 1 divided by h would be 0 because it's just multiplying by minus 1. Quick comprehension check, guys. So if h is drawn in the positive sense, as I did in my picture, right? If h is drawn in counterclockwise sense, what would you say about the ratio of sine or h over h? Is it, before I take the limit, is it bigger than 1 or smaller than 1? So is sine smaller than h or bigger than h, or they're always the same size? Speaking, so sine of h, is it smaller or same size or longer than h? Yes, Christian, wonderful. Alisa, sine can never, so here is, look at this picture, right? You see this arc and you see this red line segment. So sine will be smaller. You see roughly why? Simple explanation why is like you kind of see here a triangle. You see, so the shortest, so basically the legs of the triangle are always longer than the hypotenuse. The sum of the lengths of the triangle always longer than the hypotenuse. That's the triangle inequality, right? So that's what we know about distance, is that when you go, you're Little Red Riding Hood and you want to visit your grandmother, you go straight ahead, because if you make turns, then you are making your road much longer. Okay, so this is from this point to that point is shorter than walking from here to here. But on the other hand, you see the arc, the hypotenuse, is longer than each segment separately. Do you understand? Or have I confused you entirely? All right. I hope so. Yes, Christian, that's the second Christian. And I'll say hello, there are two Christians here. So Christian 1 and Christian 2. Good, yes. It's always nice to see. So both are good Christians, yes. So one is the morning good Christian, one is the evening good Christian. So great. So where sine, cosine, and tangent derive from? No, you can try to read about it. I do not know why historically they're called sinus, cosinus, tangents. I mean, tangents is something to do with having to touch or just grazing, right? But there is definitely, you will see my interpretation. The word sinus has to do a lot with sins. You're gonna, I'm sure, make a lot of sins in solving things incorrectly. So that's a very good name. I call it sins of the precalculus, right? For which punishment is severe from Gauss. So let's go onwards, guys. Yeah, so we understood this wonderful thing. How about this limit? Let's see how literal you are. So one thing I want you to tell me before I continue, limit as h goes to 0, sine h over h. Why would somebody have this limit? In other words, I'm asking a question that for some reason you find vague. I'm asking you, somebody is writing this. Where is somebody trying to get? You understand? So strategy, guys, right? So somebody is walking somewhere. Let's say somebody is walking along the road, running, right? Right? And then you ask yourself, where is this person running? Not just what, when you're not interested in what they're doing, moving their legs, right? You want to know what is their purpose, where are they trying to get? Because if you know that purpose, you can anticipate them, right? I learned that while chasing girls through Central Park, you know, so at night. So I, for example, know that if I just run after them, I might not be able to catch them. But if I know where she is going, I can maybe select a short, a shorter road and just catch my prey this way. Understood? Somebody doesn't understand. I think you need, I showed it to my pre-calculus. No, I showed it to office hours. Do you want to see that video again, or it's too much? 3 times, it's kind of annoying, right? Or will you suffer? How to stalk, exactly, right? So predators understand not what you're doing, but where you are going, because then you can solve the problem far better. Right? One more time, forgive me, because I did like how some of you laughed. So if you ever take, what is it, YouTube? You just reminded me, right? So sorry. Right? So if you can see it, yes? M minus n times theta equal to a minus b, and that implies that theta is equal to a minus b divided on I minus 1 over kn minus n, where m and n are, again by assumption, not the same integer. And that would imply that theta is a rational number, which is a contradiction. We are saying by hypothesis that it is an irrational number. So then this implies so you get, you saw it a few times, some of you, so you know what to expect. Yes, so for that question, that's how I know. Back to our original problem, what is somebody trying to do here? What is somebody trying to do here, guys? You understand the question, right? I'm not asking you what's the solution. Much more important that, oh my God, you all started hiding, right? You think, my God, what sort of person you deal with? Trust me, I am much worse than this. So what is sine h over h? What is it? What is somebody trying to calculate here, guys? Come on, comments. Fast. I am asking, what is somebody trying to accomplish here? You see, don't ask don't just figure out what's the solution. What is somebody trying to accomplish? The answer to what, Dante? That's already good. Answer to what? And Brandon says the derivative. Yes, the derivative. So look at it carefully, guys. If you look at this limit carefully, this is limit as h goes to 0 of sine of 0 plus h. Yes, which is 1, but goal is very important. You understand? When you realize what's the goal, you can bypass and do something else, right? So I'll show you in a moment another question. So sine of 0 plus h minus sine of 0 divided by h. And then you have this thought bubble, right? I'm not going to do this limit. Somebody is trying to find the derivative of sine x, in particular where x equals to 0, which I know is simply cosine of 0, which is 1. So of course, I need to know this limit before I know the derivative, but you see, I use this type of ideas to understand where is somebody going. Not exactly the immediate thing that they're doing. The immediate thing they're doing, they're pushing h to 0, there is a ratio. No, what is their purpose in doing it? What is the end goal, right? At least some further end goal. Because then I can intercept and do it differently, okay? You understand? Here is a simple example. Look at it, guys. Can you tell me what is this limit? I asked you to watch what the hell we are doing, right? So what is this limit, guys? So limit as h goes to 0 of the cube root of 8 plus h minus 2 divided by h. What is this limit equal to? Do it very quickly. Oh, you see, so some people already say 0. Already 3 people say 0. Interesting. What about, what do the rest of you, what do you think? Carolina, you're back? You see, guys, you right away give me numbers that you throw at me. What is somebody doing here, right? What are they truly doing? You're not opening enough your textbook or working with enough notes, right? You're supposed to solve problems. You look at it. What is your thought bubble, right? So that's the first thing. Thought bubble. Somebody is doing what? Someone is finding slope, Christian. Beautifully said. Somebody is calculating slope, or for what function and at what point. You understand? You realize that somebody is trying to do the derivatives, but you are lazy. You don't like doing derivatives this long, terrible way. So you see the formula and then you bypass it, right? You don't have to follow along the lines of this person. You can intercept them using a much nicer, easier route because you know your grounds, you know your landscape. Does it make sense what you do? So you are getting to the target. You're anticipating where this person is going. You get to the target via a much simpler road if you understand where they are going. Well, so before you answer this question, James or anybody else here, I want to hear something else. I want to tell you to tell me, somebody already said it's the derivative. Do you all see it's the derivative? Doesn't it look like the derivative? Alisa? Kind of. Does it mean an American no? Or does it mean a definite yes? So this looks immediately to me like the derivative of the cube root of x evaluated at x equal to 8. That's immediately what I see. Now, why don't you see this? One reason you don't see it is because you do not practice writing the definition of the derivative and you don't remember what it is. So if I were to take the derivative of the function f of x, how would that look? That would look in one form, it would look like this. Limit as h goes to 0, I will see f evaluated at x plus h minus f of x divided by h. We will get to the answer in a moment. I see that people do not recognize the definition of derivative, so I go back. It's an infinite descent. Yes? So you see it from this point, right? If I said write the definition of derivative, you go from left to right. Why can't you do it like in the Hebrew language? Go from right to left. Read it. So this is not visible to you. This is erased, right? And you just see the other part. Why not recover what it happened, what it was? Why can't you see the function? Right? It would be the function evaluated at something plus a perturbation. H is not even important. Perturbation means something that melts to 0, dissipates, right? And where I see the same perturbation here and here. You see, look at it. There is a cat in my room. Do you want to see it, or should I just let it free?
Show us.
See it or let it free?
Show us.
It's not her, right? It's a him. You see how it screams? It's afraid of me. It's like a student that I trapped. He almost scratched my eyes out yesterday. He scratched me right over here. You see? Got it. You cannot see it well, but got one nail here, one here. Right, a millimeter less than that from my eye. Yes, exactly. Ouch. So let's go back. What did I do to deserve that? I pressed my face into this kitty, right? That's what else would I do, right? Next time I know that next time when you torture kitty, wear goggles. Always safety first. Yeah, good. I teach derivatives to everyone, right? That's how I get a girl, you see. So she's just kissed me already, right? So it's much better that than just listening about derivatives. So here it is. So the derivative of, you see how I got it? Look at it, guys. Vision. I see 8 plus something that changed here, right? So this already reveals the function. The function is, forget about this 8. I just see this. I see this. Isn't it easy? And as I asked you, my dears, to watch what the hell we're doing, you have not watched it. You know, I can see. YouTube gives me statistics. You have not watched it. I'm very disappointed. This is my function. That's how I see it. You see, here is how I see it. Yes, here it is. At what value x? Well, it's obviously at 8. Good. Are you getting it, guys? So I cannot, unfortunately, be sticking with the same material all the time. I have to. So the answer is what? What's the derivative of the cube root of x? That's the same as x to the 1/3. So the answer is 1/3 x to the minus 2/3, where x is 8, which is simply 1/12. You see how I did it? No algebra required, just recognition. I quoted somebody from yesterday. I thought it was in English, but then I realized it was German. So it is mathematics is the recognition of dead forms. So you just see something and you recognize the dead form. Okay, that's mathematical law. I'm not sure where it's from, but I liked it. If you recognize, you solve many problems. So now, let me ask you about the same problem. What would be the limit? Remember, the limit was 1/12. What is the limit as h goes to 0 of the cube root of 8 plus 2h minus 2 divided by h? What is this equal to now? And that can be done immediately if you understood what a derivative is. David says 1/12. What about the rest of you? What do you say? Carolina says same. What about the rest of you? You see, so you inspire me to sing in Russian, honestly. Rachel says 1/6. Interesting, Rachel. Good, Minkowski. Live up to the name. We did this problem exactly. So that's what I'm trying to teach you guys, that if you view it through my eyes, the problems are trivial. You just have one problem. If you don't, you are going to solve thousands of problems in that very fat, thick book. You see, well, do you want to do this, or do you want to do this, but with this? Okay, evidently you have not watched what the hell we are doing. All right, well, any more? Come on, we just solved this problem. We solved this problem a moment ago. Just this very moment we solved this problem. So here is okay, anyhow. I need to move on, so let me quickly draw it out for you. What is the derivative? This is the perturbation. It goes to 0. What I should see on the denominator should be the same. So I put here, by wishful thinking, a 2. Now, what I have is 1/12 if I have the 2 here. But notice I put it in green. The 2 did not exist there. So then what do? I multiply to compensate. I multiply by 2. Yes, the entire thing I multiply by 2. Understand? So there is a parenthesis here, right? The entire thing I multiply by 2, so it will be 2 times 1/12. And the answer is, one person got it right. 1/6. 1/6, because you have to have Terminator vision. You see that this is the perturbation. There is no h. H is myth, meaningless, right? There is only the perturbation. You see that? Okay. Yes, you should have multiplied, not divide. You should have placed a 2 here, right? Multiply by 2, and the answer is then correct. You see how easy it is? If you realize that what you're doing is you're doing spell checking in a way, right? So you should have autocorrect right away happening in your brain, right? So for instance, if I ask you to calculate limit as h goes to 0 of e to the 5h minus 1 divided by h. And I still, you see, I'm being nice. I'm using the letter h. You should recognize the form, not the letter. What is this limit immediately? You look at it, you right away know the answer. And the answer is? Christian, is there an x? You see, you introduce an x. X is just it's a variable, right? It's just a letter representing all kind of number. You understand? So when you say 5e to the x, you're saying 5 multiplied by e by all sorts of numbers. Could that be correct? Because then you're saying the answer is kind of e to whatever number, right? It could be e to the 7, e to the 3, e to the 12. When you say the answer is e to the x. But you are getting close, right? But your old is incorrect. Careful. Christian, think about it. Okay, some people begin, maybe, I'm hoping you begin, honestly, right? I know you have at your disposal lots of, well, you know, you can go to a computer program, it can solve those things very rapidly. So I'm hoping it's from your head. I have only 2 people that, or 3 people that answer this question. What about the rest of you? Ask yourself what's being done here. Okay, another person added. Okay. What does it matter? Don't worry about getting it wrong, right? Worry about understanding. Forget about wrong, right, understanding. All right, so here is what's happening here, right? How does it look like? We have limit as h goes to 0, e to the 0 plus 5h, right? It's not, the perturbation is what I pay attention. Minus, what is 1? 1 is e to the 0 divided by h, okay? Are you with me? So then your vision is picking up, where do I see the perturbation? Here it is. It has nothing to do with h, okay? So 0, Carolina, is maybe you say 0 in a question mark, 0 what? Is the final solution 0? or just that we are doing something with 0. Okay, so I see this thing. That's my perturbation, right? What should be here? What should be here? Yes, it should be a 5. So what should be here is a 5. You with me? A 5. Because why? Because in my thought bubble, what happens? I now have a thought bubble. What is this thing? It's not my original question. I introduced the 5, right? So in my thought bubble, this thing is just the derivative of e to the x at x equal to 0. You understand? Because what you have is e to the 0 plus perturbation, and you have divided by the same perturbation, which is what? It's e to the 0, which is 1. So that's my thought bubble for this part. But I introduced something I never had before. I introduced the 5 here, so I must compensate by multiplying by 5. So the answer is 5 times 1, or 5. Are you with me? If you stay after class, I promise we can do a few more exercises like this, and we can go slowly, right? So you want to learn this technique, this idea that you recognize what you see instantly, and then many of the problems are immediate to you. So what about this one? Help me with limit as x goes to 0 of sine of 6x divided by x. What is that gonna be? Okay, good. 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 Yes, Grant, good. So for the exam, guys, when it comes, I will write it, and it will be soon that you hear about it. What you should worry about, you will have a lot of time, right? You will have plenty of time. You can ask me questions if you are worried and don't understand something. But if you write on your exam something that you don't know, and I decide to check, and I will check by talking to you, right? And it will turn on the camera, and you will talk to me, and I will see how you answer it. Then I will deduct points, and I will consider that you are cheating. Don't write on your exams anything that you don't understand, that you cannot do live in front of me, okay? That's a warning, because I don't want to have to deal with that. I would be very upset. So here is how I solve it, guys, right? I need to introduce here, instead of h, we have x going to 0. If you are not comfortable with this, right? If for some reason it bothers you that there is an x, it confuses you, you can always change the letter to h. You can say that's the same thing as h going to 0 of sine of 6h divided by h. Agreed? Yeah? So then I can put in a 6. Once I put in a 6, y is what? Y is yes, or yes, I guess it's yes, right? It's not your shorthand for why do you do it. All right, so this is equal to 1 now, right? But that's not the right answer, because we put a 6 here. There should be another 6 to compensate. So it would be 1 times 6. And the answer is 6, correct? Wonderful. So here I showed you how to do a few of them, right? So 5 times sine 5h over 5h, and the answer is 5. We solved the question that is exactly like it, yes? Now let's solve another one. Here is another one. So what we do is limit as h goes to 0 of sine h over h over, let's do it like this, not h squared, but here, h squared, okay? Like this. What is the limit, please? Alexei, what is h? What do you mean by h? I haven't seen you in a while, Alexei. Hope all is good. Okay. Don't be scared of anything. Just look at it. It's all gonna be good. All right. So you guys, you see, what do you have to look at? It's very simple. What if h is going to 0? Does h squared go to 0? Yes, it does. Yes. So you're not reading any h's. You're reading perturbations. So what's the answer? Come on, guys. Fast, fast, fast. Yes. 1. Okay. So what we do is this, guys. We have, this is my perturbation. It's supposed to be squared, so then I have to multiply by h. So now it is 0, because h goes to 0, times 1, and the answer is 0. Everybody sees how I got 0? Took me 2 seconds, yes? Okay. Okay, and here is another one. Let's see. So they can be more complicated. It's all a matter of, yes, I'll explain that again, sure. Look at it. The perturbation has to be the same. Basically, here is what sign when you read this. When you read limit as h goes to 0, sine h over h equals to 1. Notice I said h many times. That's incorrect. I should not have been saying h. What it is, it means sine of a very small number, a number that diminishes to 0, divided by same number, will result in 1. You understand? So I don't want to say h. H is just a way to communicate it. Are you with me? I'm not saying h. I'm saying sine of a vanishingly small number divided by the vanishingly small number is 1. Clear? Okay, and then what? And then when I do this limit, when I write a limit as h goes to 0 of sine of h squared divided by h squared, so divided by h, yes? You see, I cannot conclude it's 1 because there is a vanishingly small number here, but the vanishingly small number on the denominator is not the same. If they were the same, the answer will be 1. Doesn't matter how you represent it, the answer would be 1. Make sense? Because if h is vanishingly small, then definitely h squared is vanishingly small. Make sense? And they have to be the same for this ratio to be true. So I autocorrect. So I put a 2 here. Now the answer is 1. But when I squared h, I multiplied by h in the denominator. You see, when I say squared h, it's the same as saying h times h. Yes, so I multiply denominator by h, which means I have to multiply the numerator by h as well. Now the limit of h going to 0 of h, it's just 0. So you see orange becomes 0 and the other thing is 1. So it's 0 times 1 and the answer is 0 for the entire limit. Make sense? Should make sense. Yes, guys? Here is another question. Let's see how fast you will solve this one. Limit as x goes to infinity. A limit as x goes to infinity of x sine 1 over x. What is that? Great. Okay. Well, one person came with the answer. What about the rest of you? Okay. Okay. Come on, guys. Still, many of you, it's like lethargic frogs in cold water. Come on. More of it. The answer quickly. Lethargic is something that does not have energy to move. You're asking a very good questions. Do you know how scientists figured that a grasshopper is listening through its legs? So a scientist takes a grasshopper, rips one of its legs, smashes on the table, the grasshopper is jumping. Then he rips another leg, the grasshopper is jumping. Once he ripped all the legs, the grasshopper is not jumping. Conclusion, the ears are in its legs. Did you process? So what do we have here? So what you have to realize is that, okay, are you ready, guys? Look at this perturbation. Doesn't matter what x is doing, this thing is going to 0. Good. So limit as x goes to infinity, I can write it as sine of 1 over x. And to multiply by x is the same as to divide by 1 over x. Now, do you see that it's perturbation that goes to 0 over perturbation that goes to 0, which makes the limit equal to 1. Because it's really the same as h over h, you understand? There is no h, it's just when x is large, sine is getting small numbers. We divide by same small numbers. Yes? Okay, let me see if I will catch you with this one, okay? So now I'm gonna ask you to take limit. I just, to multiply by x is to divide by the reciprocal, right? If I multiply by 2, it's the same as dividing by 1/2. Make sense? So limit as x goes to infinity, limit as x goes to infinity of the cube root of 8x cubed plus x squared minus sorry, not 8, but minus 2x. Could you please tell me what is this limit equal to? It's so much multitasking. You know, I offended a German police officer today, right? I said, I hope you have a nice suppression of human rights, right? He was sending me photographs going through a demonstration, so he got offended. That doesn't matter. I'm just showing you how much a man of the world I am. Yes. So. They think that in Brooklyn, that's the worst place to be. They think it's very criminal, and that nobody mugs me because I'm Russian, and so people are afraid of Russians. That's what some Germans think. I've heard it from two already. I don't, you know, everybody obviously, you look at me, you think, my God, I'm so scary, right? Who would ever mug me? I guess Russians in Germany have some reputation, perhaps. It's infinity. All right, sorry guys that I distract you, all right? But you're solving this problem, you can do it. Here is what's happening to you guys. Who is this? Oh, that's not Arkady, like the software, you don't recognize it. Who is this? Like children, right? This is what's happening here. Or more so, like, you know, this person looks through a microscope and says, I can't see anything. I said, open your eyes, you idiot. So What's the answer? The answer is, anyone? What am I seeing here? I'm seeing here 1 over 12. That's it. That's the answer. Why? Because that's just the derivative of x cubed. Now, how do I know that? Let me do it slowly. Are you ready? Exactly. What? What? Why are you not seeing it? It's just the derivative of the cube root. Good. Good. Now let's see why that's the case. It's okay, all right, guys, but I'm trying to convince you of two things. Do it my way, it's very easy. I'm not making things hard, as some people believe. I'm making them for people that want to understand. Of course, I'm making it easy, I hope. So here is why. Look at it carefully. I can factor out the x cubed, right? So this would be the cube root of 8 plus 1 over x multiplied by x cubed. Do you agree? I'm trying to be slow here, right? Minus 2x. So far, what I did, everybody sees it. I factored out x cubed. I still keep it underneath the root. Now I will factor out this x cubed and move it out. So I will move it in here. So what am I gonna get if I do that? I'm going to get the cube root of x cubed is going to be x cube root of 8 plus 1 over x minus 2x, which if I factor out, it's x, the cube root of 8 plus 1 over x minus 2, which if I write in a different form, this would be the cube root of 8 plus 1 over x minus 2 divided by 1 over x. Here is the perturbation. It's the same. So then if x is going to infinity, this will go to 1 over 12 because it's just the definition of the derivative written a different form. You see it? Do you see it now? It's exactly the definition of the derivative. If you have in calculus 1, if you have a difficult limit, right away think it might have something to do with the derivative. All right. Are you getting it, guys? Yeah, this can be, we can practice many examples like this if you stay after class. I do not have enough time for this subject. You understand? It's just not enough time. Help me solve this problem, please. Limit as x goes to 0 of sine of 6x divided by sine of 3x. Could you solve it, please? Okay, Alan, thank you. And then the rest of you, so see what's the solution to this problem. All right. So let me ask you, I cannot see how you solve this problem, but what about this idea, guys, right? So very easy strategy is that I take sinus and I cancel it out, right? Because we have sinus in the numerator, sinus in the denominator, I cancel it out, correct? And then I can cancel out the x. And then the answer is 6/3, which gives me 2. How many of you solved it the way I just showed? I just want to see. Okay, okay, lots of people said it. Yes, many of them solved it this way. I want to see more. Come on, show me who solved it this way.
I multiplied the bottom and the whole thing by 2.
The bottom by 2. Why by 2?
To change it to 6x. Just to follow.
So you took 2 here and then you multiply it into 3, yes?
Yeah, and then it'll.
So let me see. So what you did is something like this. So you have 2 times sine of 3x, and then you move the 2 in here, yes? So it now is sine of 6x, correct? Am I understanding it correctly?
Yes, but
okay. Good that I know. Thank you. So continue writing me, guys. I want to see how many of you solved it this way, or as Carolina said, similar ideas.
But why can you cross out the sign?
Well, I didn't say. I'm asking if people solved it this way. I didn't say I solved it this way. I just said I mean, I'm not saying that I would solve it this way. Okay.
Because I assumed that's how people solved it. It just doesn't make sense to me that you're allowed to cross out the sign.
Of course, it doesn't make sense because it is wrong. My God, it could not be freaking more wrong than that. I told you it is a sin to imagine that that's the precalculus sin, to imagine that you multiply sine. Let me ask you this, right? What do you think this means? What do you think that means? Do you think it means that I'm reproducing with a student? No, it means that I am eating the student. That's what it means, right? Why do you multiply? Why do you multiply? That's not what's happening. The answer is correct, but it is this type of correct. It's like an old lady falls down the stairs, and instead of breaking every bone in her body, she becomes a beautiful young woman like she was in her 20s. That's the type of correct you have, right? It's correct by accident, which and fortune, you know, the Schutzengel, the angle, the, what do you call it in English? The angel that defends you, right? The guardian angel will not stay on your shoulders too long if you are not clever, right? Although my guardian angel has been with me way too long. I don't understand why. Right? I would have, if I were having his job, I would have long ago forsaken it. No, that's not how you solve this problem. Here is the idea. Here is what truly happens here. Are you ready? I will solve it in 2 ways to show you what you see. You have to have right concept of what's happening. Sine was not crossed out at all. Here is the method 1, algebraic, and then I'll tell you more intuitively what's happening here, right? So when I take limit as x goes to 0 of, that's why it has a good name, Grant. You see, sin, because it's the sins of precalculus. You think that you're multiplying. That's a terrible idea. It is just the name of the function. It means sine has eaten something and it digests it. How is it going to digest it? Who knows? Right? If you are interested, we can of course talk about how it digests it. How many of you have started reading quantum mechanics? I bet all of you right away. As soon as I mention, you just open the book and you cannot stop reading. That's why you haven't watched my video. It's too bad, because that is what? It's a combination of trigonometry and probability. So what we have here is 6x. And here we have sine of 3x, yes? And what do we get? This is, I can break it apart like this, guys. Limit as x goes to 0. That's my solution number 1. I'll show you another one afterwards, right? So I think of it I think about autocorrect. So I write 6x and then I write something here times, on the bottom here I have sine of 3x. And what do we see here? We don't know, right? So we broke it just like this. With me? Now, I can autocorrect by introducing x and x. Agreed? So I will put x and x. You see, because I'm making it look like something I recognize easily. Good? Now, this part would almost be equal to 1, but it needs a 6 here. You see? So I put a 6 here, and of course I multiply by 6. This guy, on the other hand, needs a 3, right? And then if I multiply by 3, I divide by 3. You with me? So then this expression is approaching 1, and so does this expression. It's the reciprocal, right? It's 1 over, it's the same thing, right? It's going to approach 1. And so the answer is 6 times 1/3, or 2. That's one way of solving it. You understood what I did here? There was not a single instance where I eliminated sine. I just observed that sine of an angle that's small, taken to the ratio of the angle, it's essentially 1. They are essentially the same. Here is a quicker way of realizing that solution. It is a quicker way of realizing. And great, Alisa, that you doubted. I really appreciate it, right? Do not, I'm trying to tell you again and again, do not trust in authorities. I am old, I am angry, I'm not happy. I can just one day decide to teach the entire class, give you entirely false information. Yes? Great. Your friend could also be part, right? Join my class, be part of the class. Understood? I can teach you everything wrong, as in fact many people do, right? As what you see on the news, some expert, right? Or Ferguson, right? And then you say, trust the experts, trust the science. Everybody has agendas. The only defense you have against anything is your brain. Don't trust me, don't trust anyone. Trust your brain. Think about it, everything. I hope so. Maybe 4 in 1, right? So I want you to be the best product. So, are you ready, guys? What about this? Second solution, right? Second solution, I observe the following. So how is it that sine h divided by h goes to 1? That means that numerator, as I showed you before, is essentially the same as denominator, right? They are very close, which means sine is not, look at it, when you say sine of h is essentially h, it means sine is not doing anything. It's like the identity function, right? So when I take the limit as x goes to 0 of sine of 6x over 3x, I'm saying this is the same limit. They're not equal. I put a star here, the same limit as simply limit where x goes to 0 of 6x divided by 3x, which is 2. You understand? I did not, this was supposed to be also sine, right? I did not cross anything out. What I did is I see the numerator, look at it. What this is saying is that when the angle is small, if the angle is small, if h is a number close to 0, then sine is not doing much to the input. It's not changing the input. Do you understand what I mean? I dropped the sine because it's not changing the input. Are you with me? It's conceptual. I'm not doing any algebra. I dropped because it's not doing anything. Do you remember the animation? Let me show you again. So you don't believe me, I think. Or if you did believe me, you would see it clearly. Here. Look at the numbers, right? Here is the angle, it's 0.151 and sine is 0.150. If I scroll it slightly earlier, look at it. Do you see? I scrolled it earlier. The angle, you cannot see it here, but they look the same. Sine and theta. Do you understand what I'm saying? You don't notice that sine is doing anything to the input. And why? Why do you have a geometric sense of that? Because of this. Look at it. The arc and the red line are almost the same length in radius units. Are you with me? In radius units. That's why you wanted this limit in radius units. All right. So back to this the drawing board. Let me see if you understand this. Here is a very easy way to verify if you understand it. Tell me what is limit as h goes to 0 of sine of h degrees divided by h. I'm now measuring the angle in degrees. What is the limit? In degrees, yes. Well, h is going to 0, so both degrees go to 0 and denominator h is going to 0. Good? Well, I mean, look at it. When you say how you answer this question, what do you measure here, right? You measure length, right? Radius is a length. So the answer is, of course, when you say ratio, the answer is in radians. Actually, the answer is a pure number. Do you understand? If you studied measurements, the answer is called pure number because it's really a relation, right? What are you relating? What is this expression, guys? There is no sign. What I see is a vertical red leg of the triangle divided by, corresponding to the angle to opening the angle at h degrees, divided by h. By basically whatever is the degrees, I convert it and put the number here, divided by h. What's the limit? In other words, this is relating to if you measure everything in degrees, I'm asking you what's the derivative of sine in degrees.
Wait,
Yes.
can you say that one more time?
I'm asking what's this limit, pretty much. Whatever I'm saying, forget about it. I'm asking what's this limit. We can say afterwards. So James says it's 1. Are you with James? Or are you not with James? So then Grant said it's 1. Are you also with Grant? Grant was a Union General, I think, correct? He used to drink as well, I think. Are you following the Union? By the way, guys, just out of curiosity, so Alan, both Grant and James, you're supporting them, right? James Madison and Grant were both presidents. All right, so Fu says 0 degrees. Okay. Come on, guys, I want to solve a few more problems before the day is over. So James says, then in radians, it will be pi over 4. I haven't been hearing much from Morning Christian. Minkowski, did you tell me what the answer is or not? No? So you're saying it would be 1 degree or something? Christian, yes. All right, let's see. Let me show you how you solve it. Right? Okay, so what is h degrees? So I'm interested in comparing. What am I doing? I'm comparing the red leg compared to the arc. You understand? I'm comparing the length of the red leg. It's just here I plug degrees to open up the angle. Right? Now, how do degrees correspond to the arc that I'm comparing to? You understand why radians are natural here? So let me see, what is 1 degree? 1 degree is pi divided by 180. Do you agree with me? Do you understand how I do it? So 180 degrees is pi, and 1 degree is pi over 180. If you need to, afterwards we can talk about degrees, right? So what is h degrees? That is pi over 180 h. So what I'm dealing with here is limit as h goes to 0 of sine of pi over 180 h divided by h, and that equals to pi over 180, because you see I can just multiply and divide by pi over 180. Do you understand how I did it? So the answer is pi over 180. Isn't it simple? Now here, hopefully that cures you from that cancellation stuff. What about limit as h goes to 0 of sine of h degrees divide, or let's actually keep it like this, sine of h in radians divided by sine of h degrees? What's the answer quickly? Yes, don't ever go with the crowd. I think there is a saying there, right? When you are with the majority, always stop and look around and think. So in this case, the degrees are on the bottom. Make sure that you see it, guys, right? So 180 over pi, exactly. So it's 180 divided by pi. There was no cancellation. Well, I mean, depends how you look at it, right? There is no cancellation of sine that I see here. Here is one more question. limit as, what about this, guys? Can you tell me what is this limit? Limit as h goes to 0 of tangent h divided by h. What is the limit equal to? And why it equals that? So one person I think says undefined. What about the rest? Fu says 1. Okay. Now the more important question is, how do you see that it's 1? It is 1, yes, but why? Because you should have a bubble in your mind. This is simply the derivative of tangent where x is equal to 0. You understand? Derivative of tangent is secant squared x, where x is 0. That simply is a secant of 0, which is 1. You can solve it other ways, but I just want you to all understand that what you are seeing here is the derivative of tangent at 0. All right, back to the first board. Now tell me, please, what is this limit? Limit as x goes to 0 of sine of 3x divided by tangent of 6x. What's the limit? Okay. And the answer is, yep. So here is what we have. So the limit please by 1/2. So this would be limit. Okay, great. Prayers are always good. So this is limit as x goes to 0. Notice the fact that we found that tangent h over h is 1 means that tangent does not modify our function either. We can see that by picture, we can see that so many different ways. So that's the same as 3x divided by 6x. I did not cancel sine and tangent. I just know they don't do much when the angle is small. And the answer is 3 over 6 or 1/2, which means that 2 or 3 people that answered it were correct. And now another question. What about this one, guys? What about limit as x goes to 0 of sine of 3x times sine of 5x divided by x squared? What is that? Good. So quickly, guys, quickly, so that I can ask one more problem afterwards. I want to ask one more problem. Good. I see three people that responded. What about the rest of you? How many? 1, 2, 3, 4, 5, 6, 7. But guys, I have 26 people here. Only 7? Come on. We can do better. I will explain afterwards, yes, but I want to hear solutions. I want you to understand it, guys. There are some people I'd never hear from, and I know those people. I mean, I see who doesn't respond. Okay, Julia, I'm sorry. Yulia. Okay. Alex, what about you? How are you? What are you thinking? You're not becoming sour cucumbers? Oh, people like probability here. Wonderful. Probably 15. Yeah, there is such a thing as pickled candy, yes.
And it's kind of very salty.
Yes, there are plenty of things, weird things, right? There is a Russian candy that's made of blood. Have you ever heard of it? What is it? It's called hematome or something. I forget what it's called. I'm not lying. You want me to afterwards find for you? That's how Russian children grow to be strong. Yes, it's made of blood. So usually they pick the person that knows math worst and they just eat him. So what you have here is this, guys. Because sine, when the angle is very small, sine is not doing much to this angle. It's really limit as x goes to 0 of 3x times sine is not going to do to 5x much, so it will be 5x. That's the quickest way to solve it. I can solve it other ways if you don't believe this one. X squared. So the answer is 3 times 5 or 15. Okay, one more problem. Would you allow me, please? And then we call it.
Professor,
Yeah.
wouldn't another way to solve it be to split them?
Yes.
And then you have the sine 3 over, okay, yeah.
No, it's good. You think of all the ways. The most important thing is you understand what they mean, right? So when a limit is equal to 1 of a ratio, it means numerator and denominator are the same. So how can they be the same? It means that if h is very small, numerator is the same as denominator. You cannot tell them apart. That's how I draw up the sign. It's just quicker than splitting. You understand? So you're absolutely correct. Here is what I do is without splitting, I say that what I see here is just 6 theta, and what I see on the denominator is 3 theta. Right? But I can of course split, and that's perfectly reasonable, right? And here you have several problems like it. You have some examples. What about this, guys? My last question. This limit, you see? What is that equal to? 1 plus sine theta to the 1 over theta. Look through those examples, guys. I am not going through all of them. Make sure that you read on your own. Or stay after class, we can solve together. Is it over? It will be over. Well, you guys, so here is the situation. Our class, if you have to go somewhere, you go somewhere, but I will stay until we answer this question. Yes, I'll record it, and if you have to go or want to go, it's up to you. I'm asking you, what's this limit? Come on, you can do it. Or are you stuck? What is this thing, guys? Look at it. Do you recognize, here is a hint, do you recognize what this limit is? Look at it. 1 plus a box, 1 over a box. What is that going to be? No? All right. Doesn't ring a bell. A bell is exactly what you can think about. Bell is the normal distribution. Should ring very much a bell. Look at this thing. It's 1 plus sine of theta to the 1 over sine of theta times sine of theta over theta. This is the limit representing E. You remember we talked about important limits, and you don't review it, guys. How many of you can calculate E? So when you see this thing, remember limit as n goes to infinity of 1 plus x divided by n to the power of n. That's e to the x. What is it really saying, right? So this is saying if this is going to be a small number. So another way of looking at it is limit of h going to 0, 1 plus a small number, because x over n is a small number, to the power of 1 over the small number would equal to e. If you don't understand it, we can go into office hours to do more of it, right? You need to know E very well. Yes? Here is why again. Here is the situation, guys. Look at it. We verified this. We verified that limit that was in one of the lectures that you don't bother reading. We verified this. How many of you remember it? Now, what it means in particular is that limit as n goes to infinity of 1 plus 1 over n to the power of n is e to the 1. Now, let's look at it carefully. This is a vanishing number. It's something that goes to 0 rapidly. Yes, it goes to 0 rapidly. So I can write it as limit as h goes to 0 of 1 plus h. Yes, and then what is this? It's reciprocal. It's 1 divided by h. If this thing is h, then this thing is 1 over h. So I see this limit, and this limit is therefore the same as the one I wrote before. It's e to the power of 1. You understand? I will say more about this limit as we go along. There is going to be logarithms, but it's e to the power of 1. Now, in the question that we just had, the question that we just solved, we had this situation. We were asking what's the limit as theta goes to 0 of 1 plus sine theta to the 1 over theta. Now, you understand that if theta is small, the quickest way to solve it, if theta is small, then this box and this box are essentially the same thing. Because remember, sine of theta is theta. Are you with me? Sine of theta, when theta is small, I just think this is the same as theta. So I see 1 plus theta to the power of 1 over theta, and my conclusion is right away e to the 1. From previous lectures, guys, which you, of course, review. Well, that is the lecture for today. There are many things I want to tell you. And of course, I can if you stay with me after class. So I'm ending the recording now.